One more case that we're going to look at now are limits that deal with infinity. So for this first case, we're going to look at our function 1 over x, and we're going to look at what's happening around x equals 0. So we're going to take a look at the left-sided limit, and then the right-sided limit, and then with that we'll be left with our two-sided limit. So our first case, x approaches 0 from the left-hand side. And actually, since we're focused on 0, I'm just going to kind of highlight. So here's 0. It's where we're getting a vertical asymptote with our function 1 over x because we can't plug in x equals 0. It'll make it undefined. So as we approach from the left-hand side, so we're getting closer and closer over here, which means we're following our graph. And this is the part of the graph that's going downward. So just to the left of our vertical asymptote, this is going down infinitely, and we can never reach 0. And as we get close to 0, it's just getting essentially smaller and smaller. So our values for f of x are going off to negative infinity there. And so for the limit, we would actually evaluate this as negative infinity. From the right-hand side, similar idea, as we approach 0 from the right, this is where our function is going up and off to positive infinity. So as we're getting closer to 0, even though we'll never reach 0, just to the right of 0, our f of x values are absolutely massive. So they would be off at positive infinity, and that's how we would evaluate the limit. We would say positive infinity. And for our two-sided limit, it's as simple as, do they match up? If they were the same forms of infinity, like both positive, both negative, then that would be our solution. But because we're seeing, as we approach 0 from the left and 0 from the right, we have a negative infinity, positive infinity, so they're not matching up, which would mean our two-sided limit does not exist. So it follows the same rule that we talked about before, that those one-sided limits have to be the same for that two-sided limit to exist. Let's look at another scenario of if we're just looking for the limit as x approaches 0 of 1 over x squared. There's a few different ways we can do this. Direct substitution is not going to help us here. If we plug in 0, it's immediately going to be undefined, and there really isn't much to do to make it defined. So we could use a table. We could also use a graph. Let's start with a table just for the sake of practice here. So we're focused on 0, but we're going to be undefined there. But what we could do is plug in some values just below it. So like a negative 0.001, negative 0.01, negative 0.1, something like that. And then we could go just above 0.001, 0.01, 0.1, something like that. Let's go ahead and have the calculator help us out with this one. So yeah, let's go ahead and keep with defining my function. So 1 over x and our x squared. That's going to be important here. We already looked at 1 over x squared. And actually what's perfect is that this is giving us our graph too, so we can work visually with it as well. Let's go ahead and create a table. And then my y values I need to change so that it's plugging into f of x. So f of x1. And let's go ahead and take a look at negative 0.1, negative 0.01, negative 0.001. And if I plug in 0, it's going to be undefined. And then just a little above. And with that, I can see the numbers are growing so much around 0, like just to the left, just to the right, I'm off at, what, 1 million. So with that, I can see that we're going off to positive infinity on both sides. And then visually, I can see that as well. Just to the left of 0, just to the right of 0, our graphs are going upward off to infinity. So with that, you can see from both sides, we're getting closer and closer to infinity, and specifically positive infinity. So evaluating this limit and seeing the graph there, as well as the table, that's going to come out to positive infinity. So those are some different scenarios where infinity, and it's we'll always have to specify positive versus negative infinity, come through for our limits.